Rules of inference. What are rules of inference? Rules of inference are pattern of reasoning establishing that if we know that a set of antecedent statements, premises of certain forms are all true, then we can validly deduce that a certain related consequent statement conclusion is also true. For example, we have modus ponens. So in this case, given P that we know to be true, and P implying Q, which is also true, therefore Q. Now, since we know that P is already true, therefore, in this case, Q cannot be false, because if Q becomes false, say true implying false, will give us a false statement. Therefore, Q should also follow to be true, so it implies that Q must also be true. Or we could come up with a truth table for this. PQ, say false, 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 true, true, false, and true, true. So if given P and the implication P implying Q, so we have P false and its implication which is true, so this is false. P false and its implication which is true, false. So P true and its implication which is false, false. And finally, P true and its implication which is true, so giving us truth. And this should imply Q. So in this case, implying Q, so false implying false is true, false implying true is true, false implying false is true, and true implying true is also true. So we end up in a tautology. Therefore, the argument is valid. Next, we have modus tollens, and not Q is true, also P implying Q is true, therefore by intuition, not of P. Why is this the case? Since we know that it's already not of Q, therefore Q is false initially. So the not of false will become true, therefore this is false. As a consequence, P cannot be true, because true implying false will become false. Therefore, not of P, because this P should be false. P cannot be true, because it will become false here in this second premise. Or we could also prove this by truth table. Say P and Q so not of Q, we have true, false, true, false. And say we have P implying Q. So we know this to be true, true, false, true. And then the result of their AND. So let's choose different color. Say we have for their AND truth, false and truth, false, true and false, false, false and truth, false. And this should imply, this will now imply not of P. In which case, the not of P will be true, true, false, false. Therefore, true implying, let's use different color for this. True implying not of P, so true implying true will be true. And then false implying not of false, which is true. So true. False implying not of true, which is false. False implying false is false. False implying not of true, so false implying false is true. This ends up in a tautology. Therefore, modus tollens is valid. We also have hypothetical syllogism. So, somewhat this looks like a transitive property. So, where you have P implying Q is true, and if Q implying R is also true, therefore P implying R must follow to be true. So using a simple truth table for this, you have PQ, false, 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 true, true, false, and true, true. So first implication will be P implying Q. R, in this case, you have a third variable. So this will be consisting of 8 rows. So false, false, true, false, true, false, and false, true, true. So you have also true, false, false, true, false, true, 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 false, and finally true, true, true. So with the first implication, you have this is P, Q, and R. So P implying Q, you will get P implying Q as this is true, 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 and in this case is false, false, true, and then true. Second one will be Q implying R. So we have true, true, false, true implying true, 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 and false, and true. So if we match these statements, so we could have P implying R. So does this imply P implying R? So for example, we have P implying R, just put it here. So P implying R is true. So false true is true. False implying false is true. False implying true is true. True implying false, false. True implying true is true. True implying false is false. And finally, true implying true is true. So if we match now the AND of these two, so true and true implying truth, that is true. So true and true implying truth, that is also true. So true and false, that will be false, implying true, that still be true. True and true implying truth, that is true. False and truth will be false, implying false, that is true. False and truth will be false, implying truth, will still be true. True and false is false, implying false, it's truth. And true implying truth will still be true. Therefore, we still get a tautology. Therefore, valid. We also have disjunctive syllogism, and in this case, we have, say, this is true, and this is true. So, given that the second statement is true, we know that P is false. So to make this true, so if this is false, then Q should be true. So Q cannot be false. Therefore Q. Or we could again prove this by truth table. That is P or Q. Say we have PQ as false, 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 true, true, false, and true, true. So the OR will be false, true, true, and true. And the NOT of P will be true, true, false, false. So the AND implies Q. So given the AND of these two, we have false and true, that is false. False implying Q, which is false, that is true. So true and true, that is true, implying true, so still true. True and false is false, implying false, that is true. And true and false will be false, implying truth, that is true. Therefore, a tautology. Hence, disjunctive syllogism is also valid. Addition, so given that P is true, you're guaranteed that if you add a certain proposition Q, whether we don't know whether it's true or false, then we are sure that P is valid anyway. So addition is intuitively valid. For simplification, for the premise to be true, we know that P should be true and Q should be true as well. Therefore, P. Or we could use its commutative statement like Q and P. Therefore, Q. So, it's perfectly valid as well. For conjunction, given that we assume P to be true and Q to be true as well, therefore its conjunction is valid because they are both true. And finally, for the resolution, say there are two cases here. Like, for example, this should be true. If P, so let P equals, say, true. So if P is truth, therefore, this case, we don't care about Q. This is already true. However, in the second statement, this is false or R. Okay, therefore, R cannot be false when P is true. When P is false, however, so when P is false, then the analysis will be, this will be false, then Q cannot be equals to false. Because P is already false to begin with, this cannot be true if Q is false. So therefore, by resolution, Q or R. Or we could settle this by a truth table, say PQ and R. So another 8-column truth table. So say false, 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 true, false, true, false, and false, true, 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 false, false, true, false, true, 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 false, and true, true, true. So in this case, we have the first P or Q. So we have P or Q is false or false is false, false or false, false or true is true, true or false, so everything here will be true. And the not of P or Q or R. So not of P or R. So not of P is true, so everything here will be true. And this will be false or R, so this will be false. False or true, false or false, false or true. And we could have the AND of these two, implying Q or R. So Q or R is equals to false or false is false, false or true is true. So true or false is true, true or true is true, false or false is false, false or true is true, and true or false, true, true or true is true. So finally will be this one implying Q or R. So true, in this case this is the AND of these two. So false and true, which will be false, implying false is true. So true and false will be false, implying truth is true. So true and true, implying true is true. True and true, implying truth will be true. So true and false is false, implying false is true. So true and true implying true is true. So false and truth will be false implying truth is true. And finally true and true implying truth is true. Therefore, a tautology, hence resolution, is also valid.